Good afternoon, everyone. Welcome back to the water stream. It's just about 3 o'clock, so if we get everyone to have a seat, maybe shut the back doors when they have a moment. Some housekeeping reminders. Please remember to scan in and scan out, not just in, but also out. Also wanted to remind folks about the trade show that's at the far end of the building during any breaks that you have. Please have a wander down there. And with that, I'm going to introduce our next speaker, Dave Brewer from USC West. He's doing a presentation on being prepared to maintain and repair your water mains. Dave has been involved with the waterworks industry since 1991 and has been with Utility Supply West Corps, otherwise referred to as USC West, since 2017. As the company's technical sales director, he works with companies such as Smith Blair Piping Accessories, H-Tech Air Release Valves, Aquapure Service Tubing, and Copperhead Utility Locating Systems. He's also a certified trainer with the EOCP, and when not working, can be found fly fishing his local interior lakes or on a mountain bike trail with his dog. So with that, I'd like to welcome Dave Brewer. Thank you.
Can you hear me?
All right. It's first of all, it's wonderful to be back with the OCP group. I was here at the very beginning, and it's great to see us still going strong today. So, repairing your water mains. Everybody's hands up. Who has been firsthand in a ditch dealing with a water main break? All right. So we're not going to be talking to that kind of water main break today. We're going to be dealing with ones that you're going to have a water main break and you need to get it going ASAP. And so more of the conventional ways of repairing water mains, we're going to touch on. I'm going to talk about some of the limitations they have and some of the ways that we can overcome some of these limitations. So when you put to head the pillow at night, you're going to be able to rest assured that it's repaired. So there's one. I mean, the internet's full of these things, right? So there we go. We got something bubbling coming to the top. We know we got to repair. And I'm sure this looks very familiar to a lot of the operators here. Uh-oh. So I also work on the concrete cylinder side of the business. So I deal with concrete cylinder pipe with the utilities across Western Canada and parts of Eastern Canada. We're currently active working with the City of Calgary. And we all know the misery they went through. This is City of Montreal. And an 84-inch concrete cylinder main. That's a bad day. That's a real bad day. The one thing I'll say quickly is, you know, I really have a huge respect for the operators that go out every day and have to deal with a system that they think and they trust is operating as it should. But I've done this long enough to know when it's buried, it's a best educated guess a lot of times. So what I'm saying is I deal with a utility like Calgary. They spare no expense. They invest heavily in their system. And they still had that happen to them. And they're not out of the woods by any means yet. So I have gained a tremendous appreciation for the operator, for the utility superintendent, for the manager who's asked to make sure this is going every day. So when he picks up the paper and he sees somebody saying, I can't believe they weren't ready. What's with them? Man, oh man, if they only knew. So we got a pipe repair. We got traffic diversion involved. Of course, is it a major arterial route? Is it easily rerouted? What's the terrain involved? Is it going to be easy to get in and access? You're going to be able to throw in a box so we can get in and enter the trench safely? Is going to be a larger engineered excavation required? These are things that have to go into your planning. Are you prepared? The other part that has become more critical, it's funny since what's happened with Calgary, Montreal, my job is working with utilities getting prepared for those repairs. What do we need? What do we have? What should I have? Do you keep them on the shelf, Dave? That's the one I like the most. Dave, and we do. Our company, we keep a large amount of inventory on what we call A-list items, 4 through 12 inch, all day long. But if you lose a 4 through 12 inch main, it's probably not the end of the world. So having parts ready and available. This becomes extra critical when isolating a water main affects critical infrastructure such as a hospital, a large portion of the population of the utility you're serving, or commitments that you have with an industry in town. You're required to give them X amount of water. They're expecting that. That's how they make their money. So when you have to isolate these type of situations, I know a lot of times utilities would rather cut off their right arm, if they could. These are amongst the many considerations the utility must consider when preparing for the unpredictable. Nobody phones you up and say you're going to have a main break at Thursday at 10 a.m. It's not the way it works. Added up, these cost money, but moreover, they cost the utility valuable time when considering that any user may not have water, right? So, again, I did the hands up. Who's been involved in water main repair? You know, when you're dealing with water mains under 400, typically repair clamp is used to quickly seal a leaking pipe and repair it quickly as possible. Hands up, who thinks a repair clamp is a long-term vessel? I guess I should have asked the inverse of that question. Oh, well. We all know, one hand's probably like this somewhere. The fact is, I have personal experience. There are some pipes that become stainless because it's row after row after row of repair clamp. Now, you do what you got to do. I get it. You get it up and running. But it's also incumbent on the operator and the utility to say, we have an issue here. We have to address this. Okay? So on the smaller diameters, the repair clamp, boom, boom, button it back up. If you go in there more than a few times, you probably get a problem with the main, time for it to come out. In these instances, the repair clamp may be ideal as they are well suited for these diameters. The clamp's ability to perform required amount of compression on the smaller radius pipe gasket is very high. I'll explain that more in a moment. However, in some instances, when you have access to the pipe and parts in stock, you got into the trench, it's an easy one to do. They don't always end successfully, right? Hands up, who's ever been in this type of situation? Tighten it up, tighten it up, tighten it up. Give her a tug or hug a few more times. She's not going to work. She's not going to work. See, repair clamps are interesting. When I'm going to break it down to you, you'll actually think it's a miracle that they work. Okay? So now you're kind of buggered. Now what do? Right? So even after the repair is closed up, you didn't have that previous slide. It's not leaking. You backfill it. You go to bed. Everything goes home. I don't know if you should have confidence that that thing is going to last the life of the pipe. I could tell you from my own personal experience, that is not the case. And I could tell you from my own personal experience, things can go really nasty. It can go nasty for the manufacturer, but it sure as heck is going to be nasty for the operator or the utility. All right? This could involve a main break that floods out homes, and those homes might form a class action suit. And then nothing but the insurance companies get involved at that point. So what I'm saying to you is that repair clamp can possibly look like that. That's not myth, that's fact. It may not happen to you. This might be just waiting to happen to you. So compounding these matters are operating pressures above 100 psi and a pipe surface less than smooth. I'm going to go back here to this one here. This has a laser, there it is right there. I can see on the surface here, pitting, right? So right away, you know you're up against it trying to make a repair clamp work. So we're talking about a pipe surface that's less than smooth. All of these things are compounding factors against you that, what are you going to do? Well, in those instances, for this reason, some repair clamp manufacturers state the limitations in the literature when using a repair clamp. It's very rare repair clamp manufacturers say on a 12-inch clamp, you're going to get 150 PSI and it'll last the life of the asset. Buy that clamp and then get it in writing really quick. Because most of them are going to have this. The pressure rating and length of the service of the repair clamp is influenced by the type of repair, extent of damage, condition of the pipe, surrounding environmental conditions, installation, workmanship at time of installation. Holy crap, do you think a lawyer got a hold of that one? Yeah, you're on your own. They basically have said that in so many words, right? And I don't blame them. I get that asked all the time. Hey, Dave, I got a 12-inch here, 125 PSI. I'm like, I have no idea. What's the condition of the pipe? What's the conditions of soils? What's the surge pressures? A lot of things go into that, and a lot of times they get used anyways. The diameter as well as the type of size of your repair can have a major role as to whether your clamp will have the capability of sealing as your pipe diameter increases in size. So I'm with Smith Blair, and the first thing you come to realize when you work with a US company is that everything is based on going to court, right? They are ready for the lawyers, so they do not overstate anything. And here we say, of the Smith Blair specifications, up to 150 PSI, depending on type of pipe, repair, diameter, service conditions, and installation workmanship. There are so many factors in there. But the big one that really I want you to notice is that as the pipe diameter goes up, look at the pressure going down. Does anybody know why that's happening? Any idea? So what's happening here? Come on. Listen, if I would have had a crayon and a piece of paper, I would have used it. So this is just something, apologies on the crudeness of this diagram, but I want you to understand what's happening here. When you're on a small radius, let's just say like 300 and under, 12 inch and under, there's a radius on that pipe that's tight enough so that when I pull right here on my repair clamp, I have a very narrow flat surface at any given time. So mostly that pull is being pulled together right there. Look at these two bars here, and then look what happens when I go up in size. Uh-oh. Okay, anyways. You see, the flatter area increases to the point so that when you're pulling down from there, it's kind of like taking a piece of paper, and instead of pulling it down like this, you're pulling it down like that. So now you have an area of gasket that could be, I don't know, up to 400 square inches. Now you have to compress all of that gasket. You got to equally compress it everywhere. Now you start to understand the challenge in a repair clamp, why it doesn't always work, and especially on the larger diameters, and especially why the pressure rating goes down when your diameter goes up. Not to mention, the shell of a repair clamp is 20 gauge, and that is 0.038. What is that, a 32nd? That's a 32nd. That's not very thick. So you've got a chunk of pressure class 350 ductile or DR25 PVC. What's your wall thickness on that? I'll guarantee you it's not 0.038. It's a lot more than that. So your repair clamp is just going to tap out when you get a bigger size, you get a bigger radius, or your pipe is not in good condition. Perfect, and I would say 95% of your applications that are going to be from, like, let's say 350 and under. Used every day, trust me, they sell thousands of them. However, when you get into some of the bigger sizes, the ability to maintain the seal diminishes. I don't like their chances of using a third clamp to get that to work. So, what do you do? Again, we're going to go back. If you've got a main, obviously we know, we isolate it, we cut in, we drop two couplings, backfill, we move on to the next problem. That's standard. And that's not what we're here to talk about today. Since what's happened with the events in Calgary, it's really ramped up. But I'm working with utilities in parts of British Columbia and Alberta where they have seen recent events and say, we need to develop a contingency emergency planning. We need to have parameters, parts in place We need to have procedure, SOPs in place so that we're ready for the emergency. Does anybody remember town of Cochrane? This happened probably late spring. A very reputable company, contractor in Calgary, very good company, was doing some telecommunications directional drilling, going from one end of the one side of the road to the other. Very easy. Not really, because when he was using the directional drilling, when he was punching through, they went through a concrete cylinder water main. That wasn't good enough. He kept going, and he went through the sanitary first main on the other side. So, and that happens. Every day we know that happens, right? The problem was, it was concrete cylinder pipe. So if those of you who aren't familiar with concrete cylinder pipe, it's a special pressurized concrete pipe. They had a plant. Canron had a plant in Cochrane back in the 70s. They made it there. This utility had no way of repairing that pipe. We got the call, and here we go. It's a fire drill. Everybody's panicking, hundreds of people involved. Can you do this, that? There was no contingency in place to deal with this. Nothing. And actually, the gentleman who works at that utility is a great guy, super guy. He left the sleepy little town of Osoyoos. He went to Cochrane, bring up his family. Great. This happened. I bet you he couldn't have gotten on a bus and gotten out of there any faster if he could to go back to Osoyoos. But you have to be prepared. And that's what utilities are starting to understand, is you need to have these insurance plans in place. So we're going to talk about what you could use. And again, this is not every instance, but these are going to be ones that you have to go back as a utility and identify, where could we use this? Where would this be beneficial? I guarantee you there's going to be some of you in here that will go back, we could use this here. So we have what's called a split coupling, and we have a bell pack encapsulation coupling. These are like a repair clamp, and that is they're modular. They come apart. When you use a coupling, you have to cut a piece of pipe out, put this coupling over, put a spool piece in, tighten it back up. With these vessels, you don't need that. So the first one is a split coupling. Basically, it's just a coupling that's been cut in half. And the next one is a bell pack encapsulation coupling. That one's a bit more technical. That one's more exotic, but it could serve a purpose depending on your utility. So we now can assemble a coupling around the pipe to repair what previously would have required isolation and cutting in. This is accomplished by split coupling into two halves. This becomes a split coupling. Extremely beneficial for replacing failed joints such as bell spigots, couplings, repair clamps, what have you. So how do we achieve this? The first thing we do is we cut it in half. We have to have a way of sealing it back up, right? So here we see an O-ring in the middle, and that is going to what we use to seal it back up. And then that same O-ring is going to interface with the coupling gasket. So we have rubber sealing against rubber. I'm going to walk through this, how this is done. And then these lug bars here are tightened up to form our compression on the O-ring. Once those lug bars are done back up, that coupling is now solid. It's a solid cylindrical object. So now you have a coupling on a piece of pipe that you didn't have to cut. Uh-oh. Okay. So the O-ring seal sits inside. So inside, now depending on the manufacturer, most of them do it this way. They have a channeled groove that sits underneath there. And most of them will probably use this AWWA C207 flange specification to determine the clamping force required on this. Then we have the gasket. The gasket, which again would be a solid cylindrical shape, is cut. Now, look at this shape here. Has anybody cut a gasket like this on a bias and then put it back into a joint? Okay, so when you I could assure you, almost all of you have used a vulcanized gasket at some point if you're putting together a coupling. If it's vulcanized, it'll probably have been cut like this on an angle. This gasket, when it's cut like that at an angle, and we put it back into the cavity and put compression onto it with the follower flanges, we'll have that gasket form one cylinder shape again. Okay? So when we use a gasket, it has to be cut on a bias. Do I have to hold this up to my chin when I do that, or? So now we're going to, you got the concept of it. Now we're going to walk through some of the utilities that have gone through these, all right? So you have an idea as to what it is that we're talking about. Yeah, that's good. All good. Thanks, bud. So this was the first one I dealt with. This was with a utility in the Okanagan. They had a steel water main failed at a couple joint. The problem with this one is that they had a really steep terrain. And so for them to do a large excavation and shore it properly, it would have been very difficult for them to do, and it was not desirable. Fortunately, they knew me. They knew the stuff that we get into, and they asked Dave, what can we do here? It wasn't the battery. There we go. So here we go. We've got this is a 42-inch line. They got a Victolic on there, and it's leaking. It needs to be replaced. So we have a fairly small excavation. And so what we're going to do is take off the coupling. Now, it's not the coupling's fault. The coupling's fine. When you use Victolic, you have to, depending if this was a restrained one, they rolled grooves into the pipe, and there wasn't an impressed cathodic protection on the pipe, and so those grooves rotted out. The coating was covered. Those two rings on the inside are going to come out. There's going to leave a very large gap. So that gap now made a repair clamp all but impossible. If the diameter didn't make it impossible already, that gap would make it impossible. But fortunately, with the split coupling, they're going to be able to use a wider coupling. They could be made as wide as you want to easily work with, because that's essentially, in the end of the day, when we're doing a coupling, that's just a pipe gap, right? Actually, this is another question I like to ask. So when you're putting a coupling on, what's the minimum gap you guys should have in a coupling? Minimum. Should the pipes be touching? No. If you leave here and you go put a coupling back on, you got to have at least a half-inch gap between the pipes, guys. All right? Here we got, 6 inches or so. So now we can see the parts of the split coupling being lowered into place. So it's modular. It comes apart, and it goes back and reassembles around the pipe. So there's no pipe moved out of the way. The followers, that's a follower flange coming down in segments. And that's what they end up having. So the repair was, it took them longer to dewater the line in this particular job than it did for them to install. It took them about 2 hours to install it. Very capable crew. And that's a larger pipe. That's a 42-inch line. That's a major feeder. But these type of fittings, we're actually in the midst of doing one with the, is there anybody here from the District of North Van? No? It's really interesting. So we're doing something similar to this on a submerged water service line. It's a 3-inch. So we're doing these as small as 3-inch. It's about 50 feet underneath the ocean. And they're going to be doing this because the ability to replace, the cost to replace the line was going to be a lot more. So we're doing these as small as 3-inch. So don't let the big size intimidate you. They will go do smaller sizes as well. This is more recent. This other one was about 7 years ago. This is very recently with the City of Kamloops. They had a 36-inch feeder main. Had a significant enough leak, discovered that required immediate repair. The method of repair was one that preferably would not require isolation. Again, it's a major feeder. They can't have it go offline. The only thing is the pumps are thrown. Anybody from Kamloops here today? There you go. Oh, of course, Preston. So what was the pressure we had in the line after the pumps were cut down, would you figure? Sorry? 80, yeah, okay. 80 PSI? 180. Oh, we're up there then. Okay, all right. With the pipe being a larger diameter, the ability of a repair clamp to provide a reliable long-term seal would be questionable. So this is a perfect scenario. When I got the call about this wasn't even a second thought. I knew exactly what we were going to use for this application, and that was the split coupling. So this is the picture of the pipe. So we can see, so the pumps are shut off at this time, but we just have residual pressure in the line. The other thing that's interesting there too, regardless of this size, if you're dealing with steel pipe, you cannot put a clamp, you can't put a saddle, and you can't put a coupling onto steel pipe if it's got that bituminous coal tar coating. That's got to come off, all right? So here we got the pipe stripped down. We can see the coating has been stripped off on both sides. And now we're going to start getting ready to take this apart. There we go. So we're disassembling outside the hole. The one thing that you have to take notice when you're doing these is there's going to be identification markers on the fitting. When it comes from the factory, when it's cut in half, everything gets assembled. And then we mark it, and then it gets cut in half. And there's markings that are put on the followers and on the body. When you reassemble it, those markers have to be lined up with one another to make sure they line up. And that's on the instructions as well. So the bottom top sections are positioned on the pipe. The lug bar bolts are installed to snug. So what's snug? That's such an objective term. I just say you do them up with your finger. When you can't do them up with your finger anymore, give it a pull or two, nothing more. That's it, snug. The lug bar O-ring is trimmed to mate with the coupling gasket seal. This is whether this fitting will work or whether it won't work. Because the rest of it after this is pretty basic coupling assembly. So you remember when I showed you that picture earlier when it had the gasket trimmed to the profile of the coupling cavity. That's what we're doing here. So that coupling gasket gets trimmed, and you have to have a razor sharp blade. Don't cheap out, put a new blade on there, and it'll go through there like butter. But we have to mimic the cavity of where the coupling gasket's going to go. The coupling gasket goes inside that cavity, and so we need those two to mate up. After carefully trimming the O-ring, the lug bars are tightened to 20 foot-pounds. So only 20 foot-pounds, no more. And when we're tightening these, we work from the inside out. Any idea as to why we're working from the inside out for the torque pattern? You got it. We want that O-ring to flow outwards, right? We push that gasket out. So we go from the inside out, just hop back and forth. 20 foot-pounds, no more. The split follower flanges are put in place and bolted together and torqued to 80 foot-pounds. They're just getting, you go metal bound. You don't get to 80 foot-pounds. Basically, the two tabs are metal bound. They go bound against each other. We do that because we want that follower flange to act as a singular unit once again. Okay? You see those markings? Those are what comes from the factory. So there's two weld dots. In this particular instance, there's two weld dots that are put on there. And I guarantee you, when you take a look at the follower flange, there'll be two weld dots on that follower flange for you guys to line it up with. Okay? The split gaskets are lubricated. Lubrication's good. Friction's our enemy here. The splice gasket should be 45 degrees from the lug bar and the follower flange joints. Note the bias cut. So we just spoke about the bias cut. So that gasket is one long cord. It's going to get fed into that cavity where the sleeve is, And then the follower flange is going to be brought up against it, and we're going to put it into compression. So this is another critical part. So there are leak paths on this thing. What we don't want is to line up all the leak paths in the same orientation, all right? We want the splice of the gasket to either be here, there, there, or there. Basically 45 degrees from each other joint. They have to be offset from one another, all right? So we wouldn't put the splice gasket in alignment with the lug bar on the end, and we wouldn't put it in alignment with the well tabs on the follower flange. Doesn't go there, and it can't go there. If the markings have been lined up during reassembly, all joints should be offset from one another. Again, we don't have the tab from the follower flange in alignment with the lug bar on the side. We don't have the gasket in alignment with the tabs on the follower there. We got the gasket right there. So everything is offset roughly 45 degrees from one another. Okay? Does that make sense? Once the gaskets of follower flange bolts are tightened in position, a final torque sequence is as follows. Again, once you've got that gasket cut, it's basic coupling assembly at that point. All right? So now we got the flange bolts. We'll do the follower flange up to 30 foot-pounds. We then go back to the lug bar. Now the lug bars, going from the inside to out, go to 80 foot-pounds. And then we have the follower flange, which goes up to a total 60, 70 foot-pounds. Once you've done that, this is like the elevator music. Let's see. There we go. All right. You ever seen that thing when your car doesn't open, you hit underneath there, it uses the fillings in your mouth? So the split coupling's in place, leak-free. The steel body is epoxy coated per C213. That there is meant to last the life of the pipe, period. All right? So that should last as long as that pipe lasts. So you've now done a permanent repair. You haven't cut into the pipe, and you're leak-free. And that day we got to put 2 of these on, didn't we? So, unfortunately, there was another hole further down. We fixed this one, and then I was driving back, and then we figured out there's another hole probably about, what was it, another 2 meters down? Yeah. Yeah, one at a time. That's all we could do is one at a time. So the split coupling in this instance, you can see it takes longer to do. I'm not going to doubt that. But I know I'm going into the hole once, not going in there multiple times. So for a bit more of an investment, you have an asset that's something that's going to provide you what should be the life of the asset or the pipe. So the repair was successful. I thought the working pressure was 150, guys, so that's wrong, but 180. That coupling's easily able to handle the 180 PSI. Agree with the installation time, roughly around 3 hours? Does that sound about right? Yeah, okay. So the hole was about 1 to 1.5 inches. So when we did the second repair, we did a larger outlet, 2-inch outlet to easily position. What we did is we positioned they come with outlets. You position the outlet over the repair so it pushes water into the trench so it's not spraying everywhere. Why are we waiting? Okay, so here's another one. This is from the City of Saskatoon. This one's probably about 7 years old as well. 2-inch hole in a chunk of steel pipe from the 50s. Very similar to the one that we just did with Kamloops. Number of challenges on this one. The main could not be isolated, much like most of the ones that we're talking about. We talked about identifying those water mains you didn't want to isolate. depth of the repair was close to 35 feet, so soil stability and shoring was a big challenge. The weather was horrible. It was wet, so all the sands, all the earth was soupy. And they wanted to do the repair live if at all possible. Again, we recommended the split coupling with flanged outlets. In this particular instance, and this is the first day they're going down there, the rains kicked in, it just became a big mud soup. So by the time we finally got it excavated, we got down to the pipe. This is what we had. Now, this particular contractor out of Saskatoon, I've worked with them a number of times, a very high quality company. They had already used a number of these on another repair we did with Sask Water, so they were very familiar with the coupling, and they did a wonderful job. They did gate valves, top and bottom. They can get whatever they want. Essentially, we rerouted the water into the trench. They did 2 trash pumps there, pumping the trench out, so everybody stayed reasonably dry. And they had this up and going in no time. So no welding, no pipe cutting, and installation time is about 2 hours. So another example of the split coupling being able to handle the requirements of the repair. No isolation. The biggest part that I like to hang my hat on is there hasn't been any need to visit the hole again because of a leak. We've done it once, right? And these are big pipes. It's one thing to have a repair let go on a 6-inch pipe. You got water bubbling up to the top. You can't have that with these big pipes. It's going to be bad. You'll look like the city of Montreal. So do it right. 7 years and counting, right? So this is a time-tested product. It will work. So that's a split coupling, all right? Very, very primitive. I think very useful in scenarios, and you need to go back and you need to identify those parts in your utility where you think those might have a benefit for you. We can also get exotic, and now we're going to talk about the bell pack encapsulation coupling. And this is one that goes up and over. So this is out of Florida. That's in a place where they have really fancy boats, and that's a sanitary force main dropping into the lagoon. So it needs to be closed off, so we did an encapsulation fitting, essentially sealing off that coupling. So the next question would be, well, what are you doing? Like, you'll have all that empty space inside because there's an annular space. Do we understand that? Like, we had to come off the pipe, so there's a large annular space. That's a place for H2S to build up. We all know how wonderful H2S is in an environment, a corrosive environment. So in this particular case, they would backfill it with a grout to take up that annular space. So the split coupling is just use a variation of split coupling, and we can go over repair clamps, couplings, bell spigot joints, or whatever is needed. Again, that repair clamp I showed you at the very beginning, where it was leaking, that's going to be a bell pack repair clamp, a bell pack encapsulation coupling, sorry. So that it looks like this, right? So this was out of the Carolinas. I think that looks like ductile to me. That looks like ductile. It might be, that looks like ductile. You have to understand, down in the US, they love their ductile, period. This is one that's a little bit closer to home. This was a 30-inch PVC line. This is with Utility Sask Water. So if you know anything about Sask Water, it's a very rural area. It's not uncommon for them to run like 20 kilometers of pipe and only have 2 isolation valves on it. So isolating and dewatering is something they'd rather not do. This was a fairly new pipe, under 10 years. So what they had is that when they backfilled it in compaction and traffic, it would leak. When they exposed it, the leak would go away. What do you think was happening there? Gets a traffic load on it, the joint pivots, the leak, somehow the gasket got pinched. The problem is it was going to cost them over $40,000 to isolate and dewater this thing. So it was very costly for them to do so. In this particular instance, what they were able to do, we worked with their engineers. We did an encapsulation fitting. So underneath there is a bell spigot joint. So we came off the pipe, landed on the other side of the pipe, and you're done. And you're not spending 40 grand, right? So this particular utility, Saskwater, it's a quality utility. They put a few of these in stock because otherwise they would be dewatering at a significant cost and downtime as well. So way more economical to go with the bell pack coupling. So the assembly of these things is very similar to what you saw, the split couplings. Very similar. The only difference is the ends are a C111 cavity, not a C219. C219 is a bolted coupling cavity, all right? Tapered gasket goes in. These ones are a mechanical joint cavity. Everybody here familiar with a mechanical joint? The joint is the gasket profile is a little different. The mechanism of seal is a little different. The reason that we do that is because we're coming off the pipe. So we put flanges, what we call a female mechanical joint flange on either end to mate with the gasket. And it just makes for a much more robust joint at the end of the day. Metro Vancouver has put some of these in for some of their sanitary force mains where they don't have any kind of resiliency or redundancy. It allows them to repair it without having to isolate. We're just about done here. This is an example of a Victaulic that's leaking again. Boy, is there any Victaulic salesmen in here? They're not going to like me here. This is in a chamber, so it's very costly, very timely for them to take the chamber apart. So what we could do instead is just put on an encapsulation fitting inside there. And again, in this particular case, they've got a pressure gauge on it. We've encapsulated, stopped the leak, and carry on. This is This is an accident. This wasn't even the waterworks job. This was some earth movers going in there, and they scraped a vital feeder main in Red Deer, except they scraped the pipe 12 feet. They scarred steel pipe 12 feet long. So there's like a big scar on the pipe. If you know anything about that, that's now a stress concentration point on the steel pipe. If they get a surge, pipe could be compromised and fail. So it had to be fixed. In this particular instance, we did split couplings, and that was a 12-foot long encapsulation. That was then filled with grout to fortify and fill all the annular space. That's the only one that I know of that Smith Blair is aware of that was in North America done. But again, and then we're actually approaching the City of Calgary. They have real problems there. They have lengths of pipe that are just done, and then rather than them having to take it all apart, this is a way of providing a solution, because all we're doing is keeping compression on the pipe. But the same principles there. Fortunately, typical methods of permanent repair are often available for utilities. So again, 95% of the repairs you guys get in every day, you're going to be able to address it. You're going to be able to address it with a typical repair clamp. But after today, when you go back, I really want you to think about some of the mains that are critical in your infrastructure. And what are you going to do to keep it going so if you do have downtime, it is as minimal as possible, all right? Especially if you have anything over 400. Preparation is key. Again, I mentioned about the recent events in Calgary, Montreal. We've seen utilities become, shall we say, more proactive in developing the contingencies plans, all right? Planning is critical. Larger diameter, what's the agent condition, what's the expected operating and surge pressures needed to be accommodated. Having this knowledge ahead of time and then preparing accordingly with fittings in the inventory will allow you to be prepared like a champ. And you go from this, that's that City of Montreal repair, to that, to that. Nothing to it, right, guys? That's it. That's all I got for you. Any questions? No, they can't. No. Now, the City of Montreal has what's called it's a pre-stressed concrete cylinder pipe, and it's a 301E. There's specialized fittings you need for that. Exact same. You do. Mm-hmm. I'm working with Metro Vancouver on that right now. Metro Vancouver, surprisingly, after this happened in Calgary, they said they're working through a consultant that I'm working with, and they said, yeah, we need to get fittings it's all part of contingency planning.
Yeah, we have, I think it's about 7 kilometers of that ACC, 700 millimeter. And so we started already trying to put isolations, like better isolations that aren't butterfly valves. We're getting some
So you didn't
stronger.
insert, like you cut in valves in with?
We're cutting in valves on the steel. It transitions to steel at some point.
Yep.
And this is all, this ACC, I believe, is all in the 70s.
Yep.
So the manufacturer, if he had a way to repair these, he's probably a very old guy by now. So I don't think
I know that guy. His name's John Braun.
Okay, and so I guess they talked with him years ago about if there was issues, and he said, just let me know and I'll come out and I'll help you repair it. But is that a viable thing to this day? I don't know. So
It is. We deal with utilities all across. I deal specifically with utilities in exactly what you just spoke about.
So
it can be dealt with easily.
So we're preparing a contingency plan to be able to shut this main down, and we've been working on it before that Calgary one burst. We were already in the planning stage of what we're going to do, and we put a sensor from the reservoir through the main and created a draw near the end of the flow of that pipe and retrieved it, and it says it's okay, like there's no fractures. Maybe our climate's a little better, but it's just a matter of time. It's a time bomb.
There was a recent conference in Calgary with the American Society of Civil Engineering, and it's all basically dedicated. And there was a wonderful, if you've ever seen that conference, if you're in charge of managing large transmission pipes, it's a wonderful conference to take. And I took in a 4-hour workshop on concrete cylinder pipe. The first 10 minutes, the manufacturer stood up and said, "We're guilty. We made crap pipe in the 70s. This is how it was made. This is why it was done." And most of the stuff that I repair is from the 70s. And, you know, hindsight's 20/20. We can look back at it, and the decisions were made at the time. But what you have is, you know, we should sidebar after this, but as you can address those issues, you have to be prepared. Because like I spoke with Cochrane, they weren't. And it's bad. There's a lot of, I don't know, the federal government somehow was involved. And when you get the federal government in anything, that's just not a good idea. So it's very possible. Metro, so you're probably with the City of Burnaby then?
City of Burnaby.
Yeah, so Metro Vancouver has an 84-inch main on Coquitlam, by Coquitlam number 4. That the same thing, they're getting contingencies in place as well. I think the pipe in the lower mainland, the concrete cylinder pipe, and we're digressing a little bit here, we're very fortunate. It's in good shape. In fact, I would say for the most part in the lower mainland, Vancouver Island, it's fairly good. You get into the Okanagan where we have hot soils, you get a concrete line, exterior that hasn't been applied properly. That's going to crack. Now you have a corrosion point that can get to the can. That's where you're going to see your issues. And if that's a whole different presentation, but it's good to hear that Burnaby's getting involved in that. And I believe I spoke with some engineers there a while ago. We should probably get together again. Yeah,
we're getting ready, and we started that process before these mains broke. So hopefully we're.
It sounds like you're halfway there. That's half the battle.
We've taken it offline, and we've experienced some pressure losses in zones, but nothing critical.
Right.
And we get feedback from a few towers that have to adjust their booster pumps.
Sure.
And a few homeowners this summer that said, "Hey, what's going on?" They couldn't water their lawns, but they didn't notice during the winter.
Yeah, summertime is the one that's easy to find that stuff. You want to do that in the wintertime. But it's a good question. We should get together afterwards.
Thank you.
Yeah, you bet. Thank you. It's a great point.
I have a question from online. 2 comments first. One says, "Great presentation, thanks." The other says, "Very informative session." And then finally a question. Do these couplings work also with HDPE pipe?
Yeah. So polyethylene is an interesting beast. Remember I mentioned the 3-inch line that we're doing? This is with the District of North Van. That's polyethylene. It's a DR11 line, and the fuse at it's a flange adapter, and the fuse at the flange is tearing, and it's got to be repaired. So we worked with the city, with the District of North Van, and what we cannot guarantee on polyethylene, it's a great question because how do you say this? Polyethylene obviously has its attributes and it's very appropriate in scenarios to use as it's very forgiving. But those same characteristics that polyethylene has don't work well with compression fittings, all right? Because polyethylene has what we call cold flow characteristics. So if I push on it here, it's going to want to flow away. So I'll try to answer it like this. With the 3-inch service line that we're working on, it's in a constant ambient temperature, that there's a temperature fluctuation of about 10 degrees. It's a 3-inch line DR11. I mean, it's a tank. It's not going to move. But we cannot guarantee that it'll never move. And as long as the utility understands that the only other way is to cut and put an insert in, we have to live with that. So polyethylene is always wanting to cold flow away. We can't stop that. Once I bolt my fitting on, it assumes a certain shape. And then that's it. It's static after that. What I would suggest to that question is that we evaluate each case on a case-by-case scenario. And I'm not going to speak from my other manufacturers, but we will say, we can't help you. And if we say no, it's because we smell trouble. We won't do it. It doesn't mean somebody else won't, but we won't do it. So, but contact me.
Any other questions? Okay, nothing online. Looking around the room. No one? Okay. Well, that concludes this session. Please remember to scan out on your way out. We'll see you back here at 4 o'clock.
Thanks, guys. And girls.
It feels like